code C1 and another second statistic that is CR. Now this second statistic CR should be lower than 0.1. And C1 is computed by simply getting the max the difference between the max eigenvalue and 4 and its expected value. We divide it by 3. 3 is the dimension of the matrix minus 1. And we get this statistic C1, which is divided by 0.9. 0.9 is a coefficient given by a table. And then we get to this value CR, which should be lower than 0.1. Let's see what happens here. Perfect. Is much lower than 0.1. So we can move forward and compute the utility of each alternative. Later on, we will try to perturb the matrix in a way that to make it completely inconsistent, and we will see what happens to the consistency checking. Okay. Now let's compute now the utility of each alternative. And I just have to do this. First of all, multiply the matrix for the weights, and then sum each row. Good. And these are the utilities. So, as I said, I multiplied the matrix for the weights and I summed each row. The first value, 0.43, is the overall utility of the design flow of, I think, 80. And then I have the utilities of the other design flows up to 120. And you see that the max utility is for the design flow of 80, which is our preferred then solution. Good. Now let's try to perturb the matrix. First of all, keep in mind that this code can be run by just making a cut and paste of the whole file. So if I select all here in this code, select all, I copy it, copy, and I just paste into R, I get the same result. So if I want to change something, it's very easy. It's just enough that I change the code. So let's make it inconsistent, as we said. And the way to make it inconsistent may be here. For instance, we may put a 9 here, which means that economics is much important than the second, which is fishery. And then I gave here a 3, which means that economic is more important than landscape, but this evaluation, if I keep this 3, it means that fishery should be more important than landscape. So when I go to 3.2, if I put a 7 here, this should be inconsistent, because I am putting landscape more important than fishery. So I think this matrix is inconsistent. Let's see what happens. First of all, okay, so if I select all and I paste it, copy and paste, oops. Okay, good. We still see that there is still, I'm sorry, but there is in making cut and paste. There was a comment. I made a mistake here. Let me do a cut and paste again. Copy. And let's see if there are errors. I don't think so. Let me check if I got any error during the... Because there are some comments that are... It seems that there are no errors. Okay, so now let's see CR. You see that CR is 0.3, which is higher than 0.1. So this evaluation is inconsistent. Okay, and still we see that there was a preference for the first solution with less dominance of the first solution with respect to the others, with respect to the first exercise that we did, but the evaluation is inconsistent. Okay, that's it. Any question?
Excuse me, about the about the numbers of the utility function. It seems like 2 times we need the engineering judgment. At first, we have to guess which numbers for the utility function,
yes,
rather than through the design flow. And other times we have to guess about the weights.
Yes.
Yeah.
Yeah. Yes, and the first decision, as I said, is done by others in this case because we are given the utility functions. But in general, we have also to define the utility function. Yes.
But about this way, I think that it increases the uncertainty because each engineering has a different numbers and they have to prove their numbers.
Yes, you mean for the utility or for the weights?
Both of them.
Yeah, for both of them. Yes, I understand. Of course, there is uncertainty, and the uncertainty is also related to the type of the audience that you have, because you mean you have a kind of way of checking the uncertainty in the computation of the weights because it's there is the consistency checking. But on the other hand, you have to take into account that your determination and assessment of the weights could be fully consistent but biased. Biased because you may have a biased audience. And this is, of course, also up to you as a chair of the discussion to try to see if there is some bias in the audience and to compose the audience in a way to make sure that there is no bias. But, you know, this is something that is part of the game. Okay, more questions? Okay, now, if there are no other questions, I would propose in 5 minutes that I rapidly go back to iMod, and I think 10 minutes are enough. And let me close this art session. And let me open another one, which should be clean. Okay. Let me remove these two. Now it should be clean. Okay, good. Now, if I go back to the previous calibration of the iMod rainfall runoff model, and you remember that we had data for rainfall and evapotranspiration and data for river flow, okay? And let me check if I already downloaded the data. No, I have to download the data, just 1 second. So let me download the data, which is rainfall and evapotranspiration data, okay? And the save page is here. This is downloaded, and data. Save pages, downloaded. Okay, perfect. Now I am ready to go back to my exercise. We had a suggested R code that you already downloaded, but the R code was just for applying iMod. And I just would like to remind to you that the purpose was to apply the iMod model for reproducing river flow, basing on rainfall and evapotranspiration data. Okay, I modified the code of R, the code of iMod, because I wanted to include in the first part the instruction for uploading rainfall, evapotranspiration, and river flow. You already did this, so you know how to do it. But for completeness, I wanted to give you the full set of instructions. So let me just copy and paste this so that I have the data. Let me see why it doesn't work. Okay, I choose the wrong directory, so sorry for that. Now it works, perfect, so I have the data. Now, the function for applying iMod is the same. Let me upload it. Again, this is something that you already have done. Okay, now I have my data and the function to apply iMod. What we did in our exercise was to try to apply it with a given set of parameters, and therefore I can write iMod, and let me take for parameter values these ones that I have given in the code because they are quite good already. So if I do this, I apply iMod, and this is what we got. A graphic with a comparison between observed black and simulated red flow, and the sum of squares here as a return result. This is what we did together, but we didn't calibrate the parameters. So how can we calibrate the parameters? I said that we may go through trial and error, or, for instance, I could apply here, I may try to change, putting 0., or let's say 2 here as beta, and I can see that the situation is changed. It is much better than before, by the way. So this is a trial and error procedure. I could change the values of the parameters, or I suggested to use an automatic procedure. What is the automatic procedure? It's an algorithm that is already included in R that we can apply to minimize the sum of squares. And when we apply this algorithm, it is advisable that we give lower and upper bound for parameters in order to limit the search range, and it's also advisable that we give a proper level of tolerance. What is the tolerance? It's the change in the objective function, sum of squares in this case, that is allowed to reach convergence. It means that if I give a high tolerance, convergence is reached quickly. If I give a very small tolerance, I want to be really detailed in the minimization, then convergence takes more time. Okay, what I'm doing, what I'm providing in this code is a suggested instruction for minimization. Let me put it in the upper part of the blackboard. I cannot modify it. Just 1 second, give me. No, okay. It's fixed. Anyway, let's look at this instruction. I think you can see it. Let me see if I can. Yeah. So, first of all, I need a dummy variable to assign the result of the calibration, and I choose PR1. You can choose whatever name you want. Optim is the function for optimizing an objective function. There are several alternatives in R. I took the most used one, okay? I need to give an initial value for the parameters, a vector of initial values. It means that the function starts from that value to search. It's advisable that you make preliminarily a trial and error procedure in order to start from quite close, because convergence is faster. And then the name of the function to minimize imod, and then the method. I choose this method. There are several alternatives. If you look at the manual, at the help of this instruction of Optim, you will find that the function can use several algorithms for minimizing the objective function. I choose this one. They are more or less equivalent, but this one allows me to specify lower and upper value for the parameters. So, these lower and upper values are to be defined according to your sensitivity, to your experience. And there are ways later on to check whether these lower and upper values were well identified. In particular, if you look at the resulting parameters and see that one of or more of them assumed the lower or upper limit, it means that there is something that needs to be corrected. So if you say, this parameter I want to test values from 0 to 1, and the parameter takes the value 1, it means that the algorithm took the maximum value that you allowed. Maybe that if you allowed 2 instead of 1 as max value, maybe that the algorithm could find a better solution. So this is the way to check after the results that you got a good guess of lower and upper values. And this is the tolerance. 1 to the power of 15, the default value would be 1e8. I enlarged it because I wanted a faster convergence. Okay, what happens if I cut and paste this? What happens is that, first of all, keep in mind that this function is run several times. imod is run several times. Each time I asked imod to plot a graph. So after launching the optimization, if I look at the graph window, I can monitor the progress. But on the other hand, plotting a graph anytime slows the procedure down. So if you want to get a faster convergence, you would need to remove the graph. So if I look at the graphical window, you see the different trials. Okay, we already converged because the tolerance was quite large, but you see the results are not bad. And if I go back to my R window, I can get PR1, the parameters, the value of the objective function, and then other messages that specify what kind of convergence I reached. And what I'm interested in are the parameter values are up there. Par. That's it. Good. I was a bit quick on this, but I think that the only problem is that you have to remind what you did, because actually what I did today is just adding one instruction, optimization. Perfect. If you have any question, please.
Excuse me?
Yeah?
We already scheduled any exams for September.
Not, but we can do that. It's no problem. And a date that I might propose is could be set something like set 12. If maybe that I could do it also on the 11, but I'm not sure. So if I need to schedule it now, I would say set 12. And before than 12, it's a bit of a problem for me. And but if you want later, it's no problem.
It's fine.
It's fine 12. Okay, I put it on Al-Mezami, then when I get back to my PC.